All right, scatter plots. Basically, this is what we've been looking at is we've been looking at linear equations, and that means that we have the same rise and run, so something is proportionally growing. Now, if you have a scatter plot, it looks a little more random. Then there's something called trend lines. So let's go look at the vocabulary. So there's trend lines and correlations, and trend line is it increasing as it moves to the right, or is it decreasing as it moves to the right? You can look at those as a positive trend and a negative trend. If they're scattered all over the place, where it just looks like a bundle of dots, there is no trend. So that would mean that the two things that you're measuring have no relationship, really. So that would be called bivariate data, whenever you're comparing your x and your y. So whenever we moved into linear equations, and you were talking about, like you'd see a table that said like, uh, 2 bags of chips cost $5, so 4 bags of chips would cost $10. You can see how that's proportionally growing. Those are equivalent ratios. They were comparing the number of bags of chips and how much they cost. That would be bivariate data. Now, whenever you're looking at real data that could vary, change by little increments, like say for example you line up 100 people and then you measure their arm span and their height, that is going to have a trend maybe, but that would be two things that you could measure and call that bivariate data. If it were true, the taller you got, the longer your arms were, you would see a positive trend. um, there would be a correlation if there is a trend. So if you see a negative trend or a positive trend, there's a correlation. Mean absolute deviation is something that is a lesson all on its own. So the thing that we're going to focus on right now is using a trend line and then trying to estimate a y equals mx plus b equation of the line. That will help you estimate what's going to take place, or also called extrapolation. Here's an example of an x and y. These are just ordered pairs that I have no idea what they're measuring, but the x and the y being compared would be bivariate data, two variables, and it would be data. So that's where bivariate comes in. You can see here that there is a positive trend. You can see it rising as it goes from the left to the right, just like if we were looking at a linear equation, we would be able to do that. So the best way to estimate a line, and the line of best fit, would be if you have the same amount of dots above and below the line. So if we did something similar like this, you can see that that's about as good as it's going to get as me drawing a straight line, but also having 2 points above and 3 points below. So what the idea is, you're using your knowledge from linear equations to estimate a line that could follow the trend of data. So notice that, I mean, if we went and did this line, it would not be straight, but you can see how there is a trend. So the things that we did before, where you could take a coordinate and another coordinate, that's all you need to make a line. So if we did y2 minus y1 over x2 minus x1, you'd end up having your slope, and that slope would have x next to it, and then you'd have y equals slope times x. Because we know whenever we're comparing bivariate data that for something to be proportional, you would end up 0 bags of chips would cost $0, right? So that would be where the line starts. Now, if we end up having a y-intercept, that would be where a line is starting here, and that could be where you start seeing negative trends. So let's just take a look at a couple of them and see what we can see. Okay, you can see that there is a trend here. Now, if you were to argue that at the very beginning right here, there is no trend, you'd be correct. It looks like it's staying pretty stable. So ticket prices remain stable all the way from 1990 to 1994. Another thing to pay attention to when you're looking at this stuff is the key. How's it being measured? So we can make estimations on this stuff. Like, for example, if you were to go over to 4, that's not 2004. This is 1990, and this is 1994. Okay, so this is 4 years after 1990, 14 years after 1990. So that would put it at 2004. Is it a confusing way to read it? Yes. Is it the most appropriate way to read it? Probably not. But that's the way they make these problems because Texas is weird. So if you wanted to continue this line in the way that it looked, you could see that there is a trend. Okay. Now, there would be a section in which you could recognize that nothing much really changed. As a matter of fact, it looks like they went down slightly and then they just skyrocketed when they hit the early 2000s. So not only you're going to be making trend lines, but you're also going to be making observations of the data. So you're going to have to read the data, read the table, read the chart, read the graph, generate a trend line. This one looks more like a curve, doesn't it? So if we went from the first point to the last point, you can see how this is not necessarily, there is a correlation, but not strong. Okay, so the data is, who knows what they're comparing. But I would say that this is a trend, sure, but not a linear trend. Here's an example of a negative correlation. You started at about 7.5 and then ended. This is more of a strong correlation with bivariate data. So a strong negative correlation. Whatever's happening with y as it decreases, x increases. The same thing happens whenever we have a negative slope. Another thing to consider that's coming up in the next unit is simple and compound interest. Instead of rolling through all these examples in the video, I kind of just want to explain what simple and compound interest are because the vocabulary is the hard part, not using an equation or a formula. So let's talk about interest. Anytime that someone borrows money from anywhere, unless there is some special deal which entices buyers to come in. Like, for example, I bought my car for 1% interest. Okay, so I had to pay for the entire car, but they only charged me an additional 1% of what it cost. So say that my car cost $20,000 and they had 1% interest. That would mean if this were simple interest, which it's not, but just for math sakes, if I had a $20,000 car and they charged me 1% interest, my car would ultimately cost $22,000, and they would pocket that $2,000. So they'd make all the money back from the car over time, and then they would have an extra $2,000. So it's more like a convenience for a buyer to be charged interest because you don't have to pay for the entire thing at once. Not many people can walk in and just drop $20,000 right then and there. So interest is a thing that allows you to pay over time, and just know that as a consumer, someone that buys something, that it is never in our favor. Interest can also work in the opposite way. So whenever you go to a bank and you're saying, hey, I want to go buy a $20,000 car, I don't have $20,000. The bank can say, well, here, take out a loan. We'll give you 3% interest over a 6-year loan. So that's the principal, the interest, and time. Time is usually measured annually, so that's per year. How many years? In that case, it's 6. The percent is going to be your interest, and the principal is going to be how much money you put down. Sometimes you can go in, say you're buying the $20,000 car, and you can say, I can put $5,000 down. Then that means you're only paying interest on $15,000. These are all things that affect the amount of interest you pay and the amount of time and the amount of payments that you have and the quantity of that payment when divided amongst the years or the months as it comes in. Earnings are the things that you get. Banks make a lot of money based on allowing people to borrow the money and charging them interest. So if I were a bank and you came in and said, I need to borrow $10, they don't just give you $10. They make you pay interest on $10. So you might owe them $1 after you pay the $10. So you'd have to pay the $10 back plus an additional dollar. So they charged you $1 for borrowing $10, costing you a total of 11. So this is where banks make all of their money, charging interest. Homes have interest on them. The larger the loan, the larger the amount of money you're borrowing, the more interest they can charge. Sometimes you can get extremely low interest rates. You can get amazing deals. And those deals are only amazing because they're going to only be taking a super small percentage of what you're borrowing. Simple interest is what us normal folk get. So simple interest is what our bank accounts look like. Simple interest is something that instead of it, in contrast to compounding, let me just describe simple. Simple is however much you have, a percentage of that is taken and then added on one time. Okay? Compound interest is every time it changes. So you could say, like, instead of just once a year you get interest, you could say once a month you get interest. And that interest gets added on. So for example, say I have $100, I made $10 in interest. Then the next time it'll be $110 I'm going to make interest on. So say I get 125 now. And then I'm going to have 125 that gets charged interest. And say I get 150 now. So you can see how it keeps building. With simple interest, it does not build. Banks use compound interest. So as the total changes, that percentage is taken and added on. That percentage is taken and added on. And the cycle continues until you reach zero. There's some key vocabulary. Annual means once a year, semi-annual means twice a year, and quarterly means 4 times a year. So that would be every 3 months. There are 2 key things that are good to know. Interest is the thing that you're paying in addition to what you're borrowing. Okay? So interest is something that if us normal people, consumers, people that buy things, were able to charge other people, we'd have more money than we currently do. Plus, we'd also be loaning money out to people. So I don't know if you've ever seen a gangster movie or anything, but if they're like, yo, Sally borrowed $8,000 from me to go bet on a football game. He owes me 8 points in interest. That means they charged 8% in interest on the amount of money that was borrowed. So not only did that guy that borrowed the money have to pay the 8,000 back, but he has to pay 8% of that 8,000 in addition to. And that is how the guy that loaned the money makes the money. And typically, if you default on a loan, like you don't make the payments, the interest can go up. And this is where credit cards make a lot of their money. So P is principal. This is the amount of money that you're going to put down. Like if you're going to go buy an Xbox Series X and it costs $500, you can finance or make payments over time. But if you were to put $200 down on a $500 gaming system, that means you're only making payments on $300 now. So that would change the payments and the amount of interest you're paying. The rate. The rate is always going to be a percentage that you always need to convert into a decimal. The easiest way to convert into a decimal is to divide by 100. Anytime you have a percent, you can always divide by 100 because it's exactly what percent means. It means per 100th. And then time is always going to be measured in years. So if we're talking about like biannual, that would be 0.5 because that's half of a year. Now, in contrast to simple interest, the formula for compound interest is slightly more complex, but not really. Just know that the order of operations applies in almost every sense. So we have the final amount is how this total keeps changing. And whenever we work through examples, you'll see that the amount is going to change. The reason we can calculate simple interest from beginning to end is because it's on the initial amount of money that there's a percentage charged. So that just automatically gets added on at the end. This is how much it's going to cost after 6 years. Compound interest is constantly changing. This is why banks use it to accumulate money versus consumers getting it in their bank accounts, because that means we would make money faster by just letting our money sit in the bank. P is the same, it's principal. This 1 is going to be the amount of money you currently have, okay? The R is going to be the rate. So think of 10 plus the 1% is going to give you like $10.10. T is going to be an exponent, and it's going to be the time in years. This exponent is why it grows faster. You could say it grows exponentially. This is the area of your formula chart, which would be at the very bottom that you're going to receive for your STAR test, your state exam. So there's no reason to remember these things other than what they mean. And there's some very easy keywords to understand. Is this simple interest or compound interest? Because you're going to be ending up with numbers left over, and you're going to sit there going, okay, it's obviously not simple interest. So with these key ideas in mind, it's just more of an awareness of vocabulary. Like what can we learn by variate data, trend lines, positive trend, negative trend, no trend, um, annual, biannual, uh, then there's simple interest, compound interest, interest amount total. There's a lot going on. So these are two completely different subjects, but there is a correlation if we were to make a scatter plot with interest and compound interest. So it's interesting. All right.